Join us on Facebook and check out the stuff that we put there. For me, for the astronomy part, people are most fascinated by A, the moon, and B, northern lights if they happen. And last night we were supposed to get a northern light show. It didn't quite pan out quite as we expected, but it still drew a lot of interest. And that was because of a couple solar flares that happened on Wednesday. Anyways, so Ron, if you wanna, let's see, I'm gonna start by getting out of the way. Yeah, set up, set up slideshow, or this one? Okay, there you go. All right, awesome. So Marlene was, who's the director over here, was nice enough to have us come into this morning, and I'm happy to be here. And she put together this presentation with a combination of people's work that they've shared on my Facebook page and work that she's accomplished over the years as well, and found as well. Obviously, we're here for the moon, so that's what we're going to concentrate on. And there's the beginning of the moon. So you can go to the next slide, Ronald. This is a theory, and it's pretty widely accepted about how the moon came into existence. An object the size of Mars collided with the Earth. There's a lot of evidence for this event. It's a theory. There's other theories out there, but this is, as I said, the most widely accepted theory. And it makes a lot of sense, and that's why it's widely accepted, because of how big the moon is, how close it is to the Earth, etc. There you go. Size of the moon, it's a quarter the width of the Earth, so that means basically 4 moons could fit right through the equator. It has a radius of 1,080 miles, and its gravity is 1/6 of the Earth. So that means it's slightly less dense than what the Earth is. And Ronald has these pictures, if you remember or seen pictures of people on the moon, they seem to be able to jump forever, and that's because of the gravity. There is gravity on the moon, but it's just much less than what's on the Earth. You can kind of think of it, I used to play a lot of basketball. If you play basketball or any sports, you jump a lot, and that means basically on the moon, you would be able to jump 6 times higher than what you did on the Earth, and that's with not any weight training or anything like that. It's just because of the gravitational difference. It also means if you were on a diet, you would weigh 1/6 your weight on the moon than you were on the Earth. Relative size and distance of the Earth and moon. Ronald had some pictures of this as well. I mean, we oftentimes, we look at the night sky, and the most obvious thing to see when the moon is out is the moon. And it's generally thought of as one of the most beautiful things. But just imagine that you were on the moon, and you were able to see an Earthrise, and how gorgeous that would be. And that's what some of the astronomers, astronauts on the moon were able to see. And if you could go back just 1 second, Ron. Okay. I would find it fascinating, me being a meteorologist, you would have different, like, we see the moon, we see the same craters, we see the same side of the moon, we're going to get into that. But on the Earth, you would see the clouds moving. A hurricane in the Atlantic wouldn't necessarily be in the Atlantic the next time you saw it. Changing the seasons, you would have a different cloud pattern and all. It would almost be like a marble where it's swirled, and it's all the time it's changing, and it would just be, I think, really fascinating to experience. I should have added, if there's any questions of any kind, please feel free to ask away, raise your hands. This is for you. Earth and moon to scale. We oftentimes, we have our 3rd grade like project, like here's the moon, here's the sun, and that kind of things. And an interesting thing that I remember did in like a ninth grade science class is try to picture what the sun, the Earth, and the moon are all in a relative, how they actually look like. So this is a good example of what the Earth and the moon is. And obviously you can see, 1, the moon is much smaller than the Earth, and 2, it's actually quite a bit further away than what we really think it is. And when we compare it to the sun is, I think I remember it was something like the size of a basketball. Then the Earth would be, if the basketball was on like the 50-yard line of a football field, the Earth would be a pea out in the parking lot, and then the moon would be like a piece of dust, like 10 feet away from the Earth. So a lot of times when you do these models, you don't show the relative size to one another. There's so much empty space and it isn't an accurate description of what goes on, but that's actually a pretty good picture that shows the relative size and distance of each of them. Go ahead, Ron, thank you.
There you go, basketball.
Oh, there, you see, there it was.
Right.
The Earth were a basketball, then the moon would be a tennis ball, 23.5 feet away. Yeah, when you compare it to the sun, the dimensions came slightly different, because the sun is so much bigger than the Earth. I forget how many million Earths could fit into the sun, and there's basically, in school, there's never any accurate way of portraying what the sun and the Earth size scale is like. It's just, you're not able to do it in a feasible manner. It's Neil Armstrong's footprint. I don't know if it's Neil Armstrong, but someone's footprint on the moon. There's another picture of a Earthrise, or a kind of like a quarter Earth or a half Earth, if you want to call it that.
Question mark, why is that? Why is the Earth, why don't we not see the whole Earth? Why is that?
Oh, well, just like we never see sometimes we don't see the whole moon, it's just the shadow that the Earth nor the moon produce their own light. I mean, yeah, the cities produce light, but it comes from something. All what we see from the moon when we're on the Earth is the sunlight reflected off the moon's surface. So, if it happens to be where the sun, the sun, the Earth, and the moon are in that order, you can see the whole side of the moon because it's all lit up. But if it's on the side or at any sort of angle, you aren't able to see the whole side that's lit up. So, for the Earth in this picture, imagine that you had this part and then went to the other side. If you could see it, it was lit up. So, generally, at any one time, half the Earth and half the moon is lit up and the other half is dark. It all depends on how much is visible, how much is facing us is how much we see. Yeah, so there's no light of its own, as I said. The Earth and the moon, or whatever you see in space, if it's the moon, if it's a satellite, you're always just seeing light from the sun. That's where it originates. It's a gorgeous picture of, and then I saw this display out there about a halo around the moon. Oftentimes you see that. It doesn't necessarily have to be a full moon, but generally it's a good indication there's a lot of high clouds out there. High clouds are often a precursor of a major, not necessarily major, but a storm system, especially in the cold weather season. In the warm weather season, it's more unpredictable just because generally the low pressure systems aren't as organized. This goes into what Ron was talking about why sometimes you only see half the full moon, why it's a quarter moon, why it's a new moon. And then the in-between phases are called crescents and gibbous. That's when you see like it's kind of like, what's the description of it? Kind of like a curved part. So in this case, we would be able to see a full moon. If the moon was over here, the light, and we're going to talk about this, would be entirely on the far side of the moon. We wouldn't be able to see it at all. That would be a new moon. And then either side of these, they would be quarter moons, either first or third, depending if the moon was getting larger or bigger. And then this is also going to play a role in why don't we have an eclipse every time the moon is full? Because if you look just at this diagram, you'd have the light from the sun hitting the Earth and then getting blocked out in a certain way getting towards the moon. So you would think that you would have far more lunar eclipses than what you do. And the key is the tilt. It says how it's 5 degrees tilted between the Earth and the moon and in relation to the sun. That because the Earth and the moon is so far apart, the shadow from the Earth, and just like any other shadow, as you get closer to an object, the shadow is big. If you get further away, the shadow is small. Because the moon is so far away from the sun, from the Earth, the shadow is really pretty small in comparison to the moon. And so unless you have it lined up perfectly, you're not going to have an eclipse. But every time the moon is in that position, you will have a full moon. Next. So here's another example of just about how the moon goes around the Earth. And so these people on the dark side of the planet would be seeing basically a full moon if you're looking right here, because there's the sun from over here, here's the moon on the opposite side, that would be a full moon here on the planet. Near side of the moon, again, there's several coincidences with the moon, the earth, and the sun. And there's two of them that are the biggest one. This is the first one. I think the next couple of slides are going to explain it. The moon rotates in 27.3 days, and the moon also orbits the earth in 27.3 days. That's a perfect coincidence. That means we're always seeing the same side of the sun, the moon, the near side. The far side, often called the dark side, that people call, if you listen to Pink Floyd, is not necessarily the dark side, because when the moon is new to us, the dark side, or the far side, more apropos, is being lit up. We just can't see it. So both sides of the moon get equal amounts of sun, but from the earth, we can only see this side of the moon. We can't see the other side of the moon, and that's a perfect coincidence. The other perfect coincidence, I don't think that's part of, you can read that, because the moon, the nearest, is that in our sky, the moon and the sun are the same relative size. And it all has to do with the moon being much closer to the earth, though it's much smaller than the sun. The sun is much bigger, but much further away. It's almost like if you didn't have, if like you were looking at a bear like 100 yards away, or a dog 25 yards away, they would seem to be the same size if you didn't have the common sense, just if you just looked out of the corner of your eye. But in reality, the sun's much bigger, but it's further away, so it looks the same, a certain size. The moon is much smaller, but much closer, and they even out. And it evens out perfectly, where they're basically entirely the same size in our sky. So that's another perfect, or very coincidence-driven fact. Go on to the next one, and there's an image of the far side. A lot of conspiracy theorists talk about the far side of the moon, whether there's strange things going on, whether it be aliens or extraterrestrials, or scientific experiments going on by different parts of the countries of the world, whether there's like mines and stuff like that. We have plenty of photographs of the far side of the moon. We are able to do that with satellites, et cetera, et cetera. You just don't often see it, because we never see it with the naked eye. We're always just seeing, quote, the near side of the moon. And it's a misnomer to call them, like I said, the dark or the light side, because they have equal amounts of sunshine. Pictures of some phases of the moon, and I knew I had a nice card here that I could hand out afterwards to help you remember some of the phases of the moon. Here they are. Obviously, the full and the lower left-hand side, that's the easiest to remember. Then we have, these are the two quarters, and the one on the top is called the first quarter, and the one on the bottom is called the last quarter. And why do you think they're called the first and the last quarter in that order? Anyone know? First quarter comes first after the new moon, so the moon is getting bigger to our eyes, and that's the first quarter. Third quarter, this one happens when the moon is getting smaller. If we were to think of this as a chronological order, these two are actually in the wrong spots. This one should be here, and they should be reversed because the moon is getting smaller. Here's the in-between phases, and we only got this picture of it. Like I said, it almost looks like a, I don't know, is that what people call like the piece of cheese, or like the small part of it? That is a waxing crescent. Waxing means the moon is getting bigger, and the crescent is like the curvy part of it. So that's a waxing crescent, and if this picture was reversed so that the crescent's on that side, that'd be a waning crescent, meaning it's getting smaller. So that is, actually Jennifer is the person that I take a lot of photographs from. She's a member of the AccuWeather Astronomy Facebook page. So that would be a perfect example of a waxing crescent. So that's getting bigger as we go through time, and it's a crescent because of that curve shape. So that is just after a new moon, probably 2 to 3 days after a new moon. Tides. This is how the moon can get related to my field of meteorology a little bit. with all the extreme storms that we've recently had, whether it be Katrina going back like 8 years, Sandy that struck the New Jersey shoreline a couple of years ago. A lot of times when there's a coastal storm, whether it be a hurricane or just a nor'easter in the wintertime or a combination of both, as Sandy was, what phase the moon in can play a role into how badly or how much destruction there could be in terms of tides. I gotta remember this is right. If the moon is in this phase right here, which would be new because we can't see it, or full, the gravity of the sun and the moon line up. So they make the tides a little bit more extreme. And so that would be called, I believe that's called a spring tide. And if we are at the quarter phases, either here or here, the gravitational pulls from the sun and the earth are sort of, on the sun and the moon, are fighting each other, and that's called a neap tide. So the tides wouldn't be nearly as high as if they were in the spring. And it's called spring not because that's what season it is, it's just the spring tide, because they're back together. They act together. Is that one of them show? Yeah, neap tide, yeah, spring tide, yeah. So each lunar cycle there's 2 neap tides and 2 spring tides, and we will often kind of look at when there's a coastal storm what phase the moon is going to be and whether that could be an influence and whether there'd be more coastal flooding or less if it was a neap tide.
Let me add something.
Yeah.
How many people saw the movie The Perfect Storm? Remember the movie The Perfect Storm? Okay.
I saw that.
All right. I was in the Navy.
Yeah.
I was in the
Yeah,
Navy.
the poster of it.
I was in the Navy then, okay? All right? And we absolutely know for a fact that the lunar was at the peak at that point,
Yeah.
which, and people think, well, you got tides, high tides on the coast. Well, what you don't realize is, out in the middle of the ocean, these tides, and I've seen them anywhere from 60 to 80 feet high, breaking waves, and that's because of the gravity of the moon in relationship to the earth and the sun. And another interesting fact about the moon is, in theory, our tides right now every year should be decreasing because the moon is moving away from the earth every year by, I believe it's something like 1.2 feet a year that the moon is moving away from the earth. So eventually, the moon's going to be so far from the earth that our tides will become non-existent.
A long ways in the future. That also reminds me, because the Earth and the Moon rotate so closely to each other, they're actually lengthening the distance between themselves and the Sun. So they're actually increasing each year a tiny amount how long the year is. And that was actually Newton and Galileo and all the scientists way back when actually knew that. They had figured that out mathematically. And remember when there was a bunch of religious conflicts, and I remember learning this in history, and I actually looked it up the last couple of days, when parts of the world were using one type of calendar and the other part was using another type of calendar, and they noticed after a while that their seasons were off, they figured out that they were about 11 or 14 days, I forget which, off in terms of the correct calendar or the astronomical calendar and the calendar they were using. So the church's idea was, well, we're going to just skip 14 days, go from October 1st to October 15th to get to where we should be. And all of that is, part of that is responsible because of the system actually lengthening ever so slightly the length of the year. I think it said it was every century, the length of the year is about 1.5 minutes longer. So it's so minute that you would never notice it, but going through century and year after year after year, it does add up. And I believe our calendar now is designed to help make sure that we stay in the right astronomical calendar and the calendar that we use every day. If you remember a few years ago, I think didn't we have back-to-back leap years one year? And that was, or 2 years, 2 consecutive years, and that's part of the reason why they did that. We just have a couple of photographs here, and here's Ron's tides. Another good example or explanation of the tides, where we have During the new moon and the full moon, we have spring tides, so the tides are a little bit more extreme as I talked about, and then probably the next screen will show, no, I was going to show the neap tides, but that's a picture of the hurricane, as maybe you could zoom in on a camera lens if you were on the moon. Another fantastic image of that's an eclipse of the moon. And you can see there that that would actually be the shadow of the Earth on the moon causing the eclipse. This was put together by a person that helps me with AccuWeather astronomy. She is great with diagrams like that. So it has names of some of the different full moons. Most months' moons have several different names. They vary from Native American names, which we use a lot, to just historical names, or just names of moons that have to do with what kind of season you're in. So for June and July, as you notice, one is like the hot moon or the strawberry moon, because that's when the strawberries would be ripe, or July is the thunder moon. July is usually the most thundery of the months in the northern hemisphere. A couple others that you may know off the top of your head is the snow moon in February, which is often called the hunger moon, and that's Native American, the hunger, because that's when they and their animals would be getting down to the end of their food supply, and even wild animals as well. Others, September, the harvest, barley, corn, or the fruit moon, all having to do with agricultural reasons, and that's when most of those things would be ripening and they're harvesting them. Another famous, when we had the supermoon. Supermoon is the Earth's orbit around the moon's orbit around the Earth is not perfectly elliptical. It varies. So it varies from when it's the closest, which is the perigee, to the furthest away, the apogee. In the whole scale of the Earth-Moon system, it's not a huge distance, but it is something like, I believe, 100,000 miles difference between the apogee. Again, that's when the moon is furthest away from the Earth, to its perigee. But in scale of how far the Earth and moon are from each other, it's not a huge difference. It's something like 1 or 2%. But a supermoon is when a full moon is at or closest to the perigee, so when it's closest to the Earth. It appears bigger in the sky. It is bigger in the sky as compared to our sun on the eyes because it's closer. And so being, it can affect tides a little bit more, and it was certainly noticeable, especially when the moon is low on the horizon. Again, another great picture of the moon, or the Earth rising, or on the moon. Some more fan photos, and Heather, again, from AccuWeather Astronomy, put this together. It's just a banner for the page celebrating the full wolf moon, which I believe was January? Yeah. Just another fan page, a photo. That's a meteorologist that I work with took that photo of the moon. Blue moon is also a special moon. I have a 5-year-old at home, and he likes watching movies, or what 5-year-old doesn't. And we watched the Smurfs the other day, and it talked about the blue moons and the Smurfs movie. Blue moon has nothing to do with the color of the moon. It has to do with the rotation of the moon is 27.3 days as we saw it. Basically, all our months are slightly longer than that. Most months have 30 or 31 days. Obviously, February is the exception with 28. So a blue moon is when you have a full moon twice in the same month. And that happens because of the difference, the 27 versus the 30 or 31. So it happens about every other year. So since it's not a common occurrence, we use the phrase once in a blue moon to, or is it either the third or fourth? Oh no, there it is right there, okay. It as something that doesn't happen a lot. So I missed to pay my bill on my credit card, but it was a once in a blue moon type of thing. It doesn't happen a lot. The second definition of that is when we have a fourth full moon in a season. And most people don't associate that with the definition of the blue moon, but there's also some pictures of the eclipse of the moon that happened this past April. Again, this was put together by various user photos that Heather put together. And that's how an eclipse occurs. As we said, the eclipse to occur, it has to be during a full moon, it has to go sun, earth, moon, but the moon has to get into that part of the shadow called the umbra. And when it does so, if the umbra gets into the, onto the moon's surface, then we have an eclipse. What we need to, no, excuse me, it's the opposite, the penumbra. When the umbra gets on the moon's surface, that's when we have the total lunar eclipse. We can have eclipses visible on one spot that aren't total, but every eclipse that we do have, there will be some spot on the globe that there will be a total eclipse, but not every eclipse is total. Again, some great photos of what lunar eclipse would look at. Lunar eclipses are special in that we can look at them. Solar eclipses are A, a little bit more rare, but B, they're dangerous. You're not supposed to look at, anytime directly look at the sun. And people during a solar eclipse get fooled into thinking that it's safe to, when in reality, there's still a lot of ultraviolet radiation that if you look at a total solar eclipse without special equipment, you can do damage to your eyes. With a lunar eclipse, you don't have to worry about that. You can look right at it.
Question, Mark.
Yeah.
I've got some students ask this question. If this is a lunar eclipse,
Yeah.
why do we have a full moon? We see the shadow of the Earth on the moon, the shadow. So why do we have an orange moon then? Why would it not be all shadowed out?
Yeah, that's a good question. I think in this case, that this is not a total lunar eclipse. So a little bit of light, just like when we have a shadow, any type of shadow, we have like the core of the shadow. But on the fringes of the core of the shadow, some light from that surface is bending, refracting along. So even in this case, up here there still is a little bit of the sun's light reaching the surface, so it's being reflected and we can see it, but it's just a lot weaker than if it was just the full the full light of the sun on it. Another good example of some a lunar eclipse. Again, neither case is a total lunar eclipse in this case, but especially this one is very close to being a total lunar eclipse. And that does my presentation. Wow. Went a lot longer than what I expected, but don't worry, Ronald's got more for you.
Sure.
You want me to run the computer
No,
for you?
I'll get it.
You got it.
Yeah, you folks don't mind if I